Hi everyone, I am the founder of the Grey Blind Owl. Today we will continue to talk about pointers. Unlike the previous lesson, in this lesson we will learn how to access array and matrix elements with pointers. You should not think of this as a different subject than what we learned in the last lesson. What we used in the previous lesson, we will use the same in this lesson. Except for some minor changes, there will be no other difference. We include our library hashtag include stdio.h. We create our main function integer main brackets and the curly brackets. We create two integer variables I for counter and n for limit. I is equal to 0 for counter and n is equal to 5 for the limit value. We create an array 5. So our limit value for array is equal to 5. Integer array 5. We create a pointer to keep the addresses. Integer star pointer underscore array and semicolon. Now, we want the user to enter 5 integer numbers and get it for a for loop. Here, execute, compile and run. We are here now. Please enter 5 integer numbers. Please enter the first number. Okay, we create a for loop here. This is the classical structure. I is equal to 0, our initial value, and I is less than n is equal to 5, so I is less than 5, I plus plus. This is our condition, and this is the increment ratio. Okay, printf, please enter the person sign D number, I plus 1 because I is equal to 0, so we need to increase 1 unit our I value. And semicolon, scanf the person sign D, ampersand array I, and semicolon. This is a classical method. So we get the number. Please enter the first number. I will enter here 1. The second number 2, the third number 3, the fourth number 4, and the fifth number 5. Okay. Now, we entered 5 lastly, and we have to know that array elements are sequentially addressed in memory. Let's see the addresses of the elements. Okay, for I is equal to 0, I is less than n, and I plus plus, printf, the person sign D number. So, the first person sign D means I plus 1. Okay, the first number here. And the person sign D, our number, so array I. And the person sign D's numbers, address. So, I plus 1. And the person sign P is an address, so we will enter here address of array I. Now, the first number is equal to 1, and the first number's address is equal to 6 2 F D F 0. The second number is equal to 2, the second number's address 6 2 F D F 4. The third number is equal to 3. The third number's address 6 2 F D F 8. The fourth number is equal to 4. Our fourth number's address is equal to 6 2 F D F C. The fifth number is equal to 5. The fifth number's address 6 2 F E 0 0. So 0 plus 4, 4. 4 plus 4, 8. 8 plus 4, C. So 12. C plus 4 is equal to 16, but in the hexadecimal system, 16 is not provided. Okay, 16 is not provided, so we enter here 0 and we increase this side 1 unit. We increase this side 1 unit. So f means 15 and 15 plus 1 is equal to 16. 16 is not provided in hexadecimal system. So we are 0 here again, and we have 1 unit. We have 1 unit and we add this 1 unit here, d plus 1. So d means 13 and d plus 1 is equal to 14 and e here, as you can see. Why we add 4 point? Because integer type is required 4 byte. So 0, 4, so we add 4 byte, and 8 we add 4 byte again. C, so 12, we add 4 byte, and we add 4 byte again, 0. Okay, this is our method by using addresses. Now let's come to our main topic. To access the array elements, we place the address of the first element of our array inside our pointer. Pointer array is equal to array and semicolon. This is a new method. Actually, this means pointer array is equal to address of array 0, the first element. But we can write this expression like that. Array. Only the name of our array. Okay? This means this is our first element of our array. These two methods the same thing, but the first one is more common and more useful than the second one. The first one is more common and more useful than the second one. Okay? Now, what is in the pointer and what is the pointer's address? Let's check it. What is the pointer? What is in the pointer? Sorry. 6, 2, F, D, F, 0. As you can see, our first element, 6, 2, F, D, F, 0. They are the same address. So our pointer has the first element's address in it. Okay? What is the pointer's address? 62FDE8. This is our pointer's address. Now we can access the array elements via our pointer. For I is equal to 0, I is less than n, I plus plus. Printf the person signed D number here, I plus 1, and number is equal to the person sign D. So here, be careful. Star, brackets, and pointer array plus I. Star, brackets, and pointer array plus I. This is the same thing with this. But we have to put this address in our pointer. Okay? We have to put this address in our pointer if we want to access our array elements via our pointer. Okay? This is the method. Like the referenced value. Actually, the referenced value. The person signed D numbers address, so I plus 1, the person signed D numbers. And pointer array plus I for the address, the person signed P. As you can see, they all the same. They are all the same. The first element and the first element. The second element and the second element. The third element and the third element. And 4, 4, 5, 5. They are all the same. We add only one unit this address. This means multiply this unit with your size of your variable type. So our variable type is an integer type, and an integer type is required 4 byte. So 4 byte times 1 unit is equal to 4 byte. At this address 4 byte. Okay, as you can see, 0 plus 4 byte 4 plus 4 byte 8 plus 4 byte C, like that. Okay, so we add only 1 unit here. This means 4 byte added. Matrix part. We create two integer variables, row and column, for counter. We create a matrix and fillet, matrix 2, 3. We create a pointer to keep the addresses, pointer underscore matrix. Here, our matrix is equal to 1, 2, 3 for the first row, 4, 5, 6 for the second row, and our pointer here, integer pointer, pointer matrix, and semicolon. Let's see the addresses of the elements. For row is equal to 0, row is less than 3, and row plus plus. For column is equal to 0, column is less than 3, and column plus plus. Printf, the person sign D, so our row number, and the person sign D, our column number, here row plus 1 and column plus 1. And our element, the person sign D, matrix, row, and column, and the elements address, the person sign P, address of matrix, row, and column. Now, let's check it. Matrix part here, matrix part. The first row and the first column is 1 and address blah 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 0. The second column is equal to 2 and address 4. Third, 8. 2, 1, 4, and C. 2, 2, 5, and 0. 2, 3, 6, and 4. As you can see, 4 byte, 4 byte, 4 byte. Always 4 byte. Okay, to access the matrix elements, we place the address of the first element of our matrix inside our pointer, like arrays, Here, pointer is equal to array and address and semicolon. Pointer array is equal to address of array 0. We use that. We will use that here. We will use that here because I want to show you its usage. Pointer matrix is equal to address of matrix 0 and 0 and semicolon. Let's check our pointer. Printf what is in the pointer, the person sign P, pointer matrix, and printf what is the pointer's address, address of pointer matrix, and semicolon. Here, 62FDD0. This is our pointer's value, so this is also our first element of our matrix, 62FDD0. Okay, and this is our pointer's address, 62FDC8. Okay. Now we can access the matrix elements via our pointer. For row is equal to 0, row is less than 2, and row plus plus. For column is equal to 0, column is less than 3, and column plus plus. Printf, the row number and the column number, our variable name and our variable value, and elements address, the person sign P. Here, pointer matrix plus row times 3 plus column. Okay, this is our method. We multiply these row number with our column number, and after that we add the column. For example, our row is equal to 0 and column is equal to 0, so that 0 times 3 is equal to 0, so column is 0, pointer matrix, only pointer matrix. pointer matrix plus 0 pointer matrix, and pointer matrix plus 0 again pointer matrix. So this is our first element. For example, 1 and 1. 1 and 1. Pointer matrix plus 1 times 3, 1 times 3, plus column, so 1, pointer matrix plus 4. Pointer matrix plus 4. 4 times 4, because integer type is required 4 byte. We add 16. So as you can see, we are here now. Okay. This was the matrix part. Now we know the matrices and arrays consist of a collection of addresses. We can see other ways of expressing array and matrix elements. Although they are not very critical at this stage and they are not widely used, they will be much easier to learn when our subject is addresses. If you think of it as if we were using an star for each square bracket we removed, you won't have any trouble. This is for the arrays. For I is equal to 0, I is less than 5, and I plus plus. Printf the person sign D, number of the array, and the person sign D. I plus 1 for D is the person sign D, and star array plus I for this person sign D. We removed the square brackets. And we put star instead of the square brackets. Okay, we put the star sign instead of the square brackets, and we add this index to our first address. Okay, this is an alternative usage. As you can see, we are here 1, 2, 3, 4, 5 alternative, and here 1, 2, 3, 4, 5. They are the same, but their methods are different. For the matrices, for row is equal to 0, row is less than 2, and row plus plus. For column is equal to 0, column is less than 3, and column plus plus. Printf the person sign D row and the person sign D column is equal to the person sign D and the person sign D. There are two alternatives here. If we removed the columns square brackets, we have to use that. A star matrix square brackets row plus column index. This is same the array, but we have a square brackets again because we have row in this situation, and we do not remove this, and star matrix row plus column. If we want to remove again these square brackets, we use second star and brackets and star and brackets, matrix plus row plus column, and close the brackets and semicolon. They are all the same. Here 1 1 1, 1 2 2, 1 3 3, and 1 2 3, 2 1 4, 2 2 5 and 5, 2 3 6 and 6. Okay, as you can see, they are all the same. We finish our program here, return 0. That is it for this week. I know they can seem very confusing, but I am in charge of explaining all the details to you. It is unlikely that everything I have said in this lecture will come to your mind at once. I can assure you that this math is specific to this topic. In particular, I strongly recommend that you repeat the last lesson and this lesson by downloading the sample codes below and making changes to them. Next week, we will introduce the functions, and if these subjects are well learned, you will not have any difficulties next week. Thanks for all your effort and your patience. See you following lecture. Stay tuned.